Hi everyone, this is the lesson for 10.4. So we're talking about a different type of angle inside circles for this section, and they're called inscribed angles. So an inscribed angle is an angle whose vertex is on the circle, and then the sides are chords of the circle. So the vertex this time is on the circle instead of being in the center like it was in 10.1. That's a central angle. This is an inscribed angle. So if we take a look at this circle down here, this angle here would be an inscribed angle because B is the vertex and it's on the circle. So this angle ABC is an inscribed angle, angle ABC. So that's when the vertex is on the circle. So if you notice, we have the arc that it intersects, like where it cuts off. If we got rid of that, that would be just this part of the circle. And that's called an intercepted arc because that angle is intercepting it. It's meeting it. So it's an arc with endpoints on the sides of a inscribed angle. So that would be arc AC, like what we just talked about. So this arc is arc AC, and that's an intercepted arc. So if you remember back from 10.1, we talked about how if we have a central angle, if it's touching at the center, then those are going to be the same degrees. The arc and the angle will be the same if the center is on, or the vertex is on the center. Well, here our vertex is on the circle instead. So this angle B is not going to be equal to the arc. It's actually half of the arc. So if we're looking for the measure of the inscribed angle, this angle right here, it's half of the arc it intercepts. And the reverse of that is true, that the arc AC would equal 2 times the measure of angle B. So going both ways. So if we're finding the angle, we take half of the arc. If we're finding the arc, we double the angle. So our first corollary, which is, remember, a baby theorem that comes from another theorem. So they have the similar concepts or similar ideas. So this says that if we have two inscribed angles that intercept the same arc, then they are congruent. So if you look, angle B here intercepts this arc here, and then if we were to highlight angle A, it touches the same endpoints of that other arc, so those two angles A and B are congruent. So our next corollary says that an angle inscribed in a semicircle, remember that was half, is always a right angle because it's going to be half of 180 because half the circle is 180. So this is, if it opens to a diameter, the angle is always going to be 90. So our next theorem says that the opposite angles inscribed in a quadrilateral, so that would be like angle A and C. So the opposite angles of a quadrilateral inscribed in a circle are always supplementary. So if we take a look at this picture, that means that angle A and angle C are equal to 90, or 180, I'm sorry. So angle A plus angle C equals 180 because they're supplementary. And then angle B and angle D are 180. So if they're opposite each other, if it's a quadrilateral, they're always going to be supplementary. And our last theorem is pretty much just a different version of this one. It's telling us the same thing, that the angle equals half the arc. Our angles are just in kind of weird spots. So the measure of an angle formed by a tangent line. So this isn't two chords. Remember, a tangent line touches the circle in one spot. Okay, so the angle formed by a tangent line and a chord is half the measure of the intercepted arc. Okay, so angle C, So that would be this angle here or this one. Okay, those are going to be half of the arc that they cut off. So their measure equals 1/2. So that would be this arc here, BDC, or BDC in that picture. Okay, so it's the same idea as the other theorem. It's just instead of doing 2 chords, so 2 lines inside, it has 1 line inside and 1 line outside. Okay, so let's take a look at our examples on the inside. We got quite a few of them. So I think sometimes for these it helps if you highlight the arcs and chords so you can see what things open to each other, especially when the pictures get more complicated, like number 4, when you have a lot of things going on. Okay, so this is our inscribed angle, and it opens up to this arc AC. So our inscribed angle is always half of the arc, so that means that x would be 50 degrees. Half of the arc. So number 2, same idea. Here's our inscribed angle, angle x, and then this is the arc that it opens up to. So angle x is equal to half of the arc, so x would be 60 degrees. Okay, so for question 3, it gets a little bit more complicated because they didn't give us exactly what we needed. So take a highlighter or you can trace it with your pen or pencil. So here's the angle we want, and this is the arc it opens. Well, they didn't tell us the arc or the angle, so we need to figure out one of them to be able to find x. So if we knew this arc, we would know that x is half of that. So they told us the other 2 pieces of this circle, so can we find out what this arc is? Very good. The whole thing adds to equal 360. So if we subtracted those from 360, we would have arc AC. So 146 plus 110 is 256. 360 minus 256 is 104. So that means that this arc AC is 104. So to find x is half of 104, so x is 52. So for question number 4, this is one where I would definitely highlight because there's a lot of stuff going on. You're finding different things, they give you different pieces. Sometimes it's hard to tell which one to do first. You're not necessarily always doing x first, but if you highlight them, you can kind of see what you got. So I can see that x is this arc. So I'm going to highlight the angle that touches it. So that would be this side, or that intercepts it, and this side. So remember we said that the arc is, or the angle is half the arc, but the arc is twice the angle. So the arc would be 2 times the angle. So x is 120. I don't know why I wrote that. 120. Okay, so now let's try to look for y. So angle y is formed by those 2 sides. So if I trace the arc, it has the part that we just found that was 120 and this 30 part. So y is going to be both pieces together. So y is 150. Okay, so let's look at number 5. So here's my angle x, and it opens to this arc. It's open to a diameter. So remember what we said, if it opens to a diameter, then it's always going to be 90 degrees because it's half of 180. So here's y. Y opens to that arc that's 70. So y would be half of 70, so 35 degrees. Very good. Okay, so for number 6, if we trace our arc, or the angle that they want is this one, so that is open to arc AB, which we don't know what arc AB is. They didn't give it to us, but they gave us the central angle. So remember, the central angle equals the arc, and then the inscribed angle is half of the arc. So x would be half of 60, so x is 30. So this is kind of a common problem that you'll see. They'll give you like one of those and you have to find the other two. So remember that this inscribed angle is half of the central angle, which is equal to the arc. Okay, so here's our x. This is another one that's open to the diameter. So if it opens to the diameter, then that means your angle is 90. Okay, so for number 8, if we trace that one and the one for x, we can see that they're open to the same arc. So if two angles are open to the same arc, then that means that they are congruent. So x is just 68. Okay, so question number 9 is one of our problems that we can use that last, not the last theorem, but the second to last corollary that says that opposite angles are going to be supplementary if it's quadrilateral. Okay, so that means that y and w would add to be 90 and x, or add to be 180, and x and z would add to be 180. Okay, since x and z are both open to a diameter, then we know that they're both going to be 90. So let's list out w, x, y, and z. So we just said that we know x and z because they're open to a diameter. So those are both 90. And as you can see, they're supplementary. They add to be 180. So let's take a look. W, we don't know anything about those arcs, so we can't find that first. So we're going to find y first. So I'm going to trace y. So I can see that y is open to that whole arc, those pieces together. So that would be 60 plus 80 is 140. So y is going to be half of 140. So we got that y is 70. And then I know that y and w are going to be adding together to equal 180. So I can subtract that from 180 to get w. So w would be 110. Okay, so for question 10, they want us to find the measure of angle ETA. So I'm going to trace it so that way you can see what I'm finding. So this is the kind where it's a chord and a tangent line. So that means that it equals half of that arc TE. Okay, but if we take a look at what they gave us, they told us that this angle is 38. And that angle is also open to chord TE. So then that means that the angle that we want is just 38. So angle ETA equals 38. And that's because those two angles are open to the same arc. So they're congruent. Just like question number 8. The picture just looks different. Okay, so for 11, this is just like question number 9. Remember that opposite angles are supplementary. So A and C add to be 180, and B and D add to be 180. So why don't you go ahead and pause your video and try question 11. Okay, so I wrote all of it out. So if you trace, I want you sneaking ahead. If you trace angle A, you can see that angle A opens to these two arcs together. So that's why I said it was half of 100 plus 90, because I was showing where I got the numbers from. So that would be 190, so half of 190 is 95. And I did that way for all of them, but once I found A, I could have done 180 minus 95 to get C. We know those are supplementary, so I didn't have to write it out for C. I just wanted to show you another way to do it. Okay, so if you have any questions on that one, make sure you ask in class. So let's take a look at our last question. So they said to find the measure of angle HFG. So I'm going to highlight it. So I know that that angle will equal half of this arc that it intercepts. So if we can find that arc, then we'll be good. So then they told us that the measure of arc HJF, so HJF, is equal to 212. So we if we knew this arc, we could find half of it to get that angle. So remember that they always add speed 360. So 360 minus 212 is, I don't know why, okay, so 148. So this is 148, so we could do half of 148 and get our angle. So the angle HFG equals 1/2 of 148. So that would be 74 degrees. So there was another way to do it. On here, I did it differently. They told us that, so I found the measure of this arc. I got 106 here. And then those are supplementary. So I just subtracted from 180. And I still got 74. So it doesn't matter which way you do it. So either way, you're doing some subtraction and then some halving. So it doesn't matter. Okay, and that's it. Warner out.